Hello, today we are going to study a complex example of a redox reaction. This reaction is between potassium permanganate in aqueous solution, between ferrum chloro 2 in aqueous solution, hydrochloric acid in aqueous solution. You get potassium chloride in aqueous solution, manganese chloride 2 in aqueous solution, chlor 2 gas, ferric chloride 3 in aqueous solution, and water. Step 1. Capitalize the degree of oxidation. We start at the end, -2 for oxygen, +1 for potassium and manganese, in this case would be +7. Ferrum chloro 2 is -1 for chlorine, +2 for iron. Rule of the cross. Your chlorine has chlorine at chlorine -1, hydrogen +1. Potassium chlorine has chlorine -1, potassium +1. Manganese chloro 2 has chlorine -1, manganese +2. In simple matter, chlorine 0, ferrum chlorine 3 has chlorine -1, iron +3, in water -2, hydrogen +1. Let's emphasize which elements have changed oxidation degrees. This is manganese. This is iron. And this is chlorine, which goes to 0 charge. We make 3 half reactions in this case because there are 3 elements changing oxidation degrees. That's what makes this example so difficult. Next. Manganese from +7 goes to manganese +2. Manganese will accept 5 electrons. Iron from +2 goes to iron, +3, gives up 1 electron. Chlorine from -1 converts to chlorine, 0. But the chlorine molecule has an index of 2. Let's take that into account. And chlorine will give up 2 electrons. That makes 3 changers. What do we do next? The electrons that accept are 5. The electrons that give back add up to 3, 1 + 2. Next, 3, and 5 crossed over and crossed over. Oxidizing manganese is reduced, reductive ion oxidizes, chlorine reducing agent oxidizes. Let's put 3 for manganese, which has the lowest oxidation state, 5 in front of ferrum chlorine. 2, here, iron has the lowest oxidation state, and we'll put 5 in front of chlorine 2 since it's a simple substance. Addition factors. Manganese on the left is 1, manganese on the right is 3. In front of potassium, manganese O43. Next, potassium 3. Here, potassium 1. In front of the formula potassium chlorine, we put 3. Iron on the left side is 5, on the right side is 1. In the formula before ferrum chlorine 3, we put 5. Now count the chlorine. Chlorine 10 plus 111. That's on the left. On the right, 3 plus 6, 9 plus 10, 19. In the given context, consisting of 10, 19, add 15, 34. This results in 34. But since there is already a 10 present, the sum becomes 24. Kindly pass me the chlorine. Combining it with hydrogen, 24, produces 2. Introduce a factor of 12 before the water formula. Let's verify the oxygen levels. The left side contains 12 oxygen atoms, and the right side also contains 12. Thus, the equation is balanced. However, this example is complex due to the presence of 3 modifiers in this reaction. Now let's proceed in the following manner. Electrons can either be relinquished or acquired and must subsequently be accounted for. This is the method applied when dealing with intricate scenarios involving redox reactions. Goodbye.